Okay, so in order to review for our test, I want you to do a quick write. So number 1 asks you to explain 2 ways for how to check if the solution 2, 3 is a solution of the system below. So this is a system of inequalities, and you need to decide 2 ways to check if 2, 3 is a solution. Secondly, I would like you to write down what is similar and what is different about these 2 lines. Okay, so somebody tell me one way to check if 2, 3 is a solution to this system of inequality. Michael? Plug them in, or more specifically, substitute, correct? So the easiest one to substitute would be y. Here's y. If y equals 3 and I substitute for y, I would get 3 is less than 5. Is 3 less than 5? Yes, that works. All right, so now let's substitute both of our values into the variables. So I have y is 3 is greater than or equal to 2 times x, x is 2, plus 1. When I simplify this, I get 3 is greater than or equal to 5. Is 3 greater than or equal to 5? No. So this is false. This is not a system of equations. What is it, then? What would that look like? Let's come back to that. All right, let's look at the second one. Second one of this one. Who can tell me another way to solve for this system? Any idea? Yes, Elgin. How could I put, substitute the 5 in for y. Well, normally we would do that, right? But that would just give me the answer for x. I'm trying to figure out whether this specific location on a graph is a solution to this system. Okay, so I'm going to make a very rough sketch now. Okay, just quickly make a sketch. The other way to decide would be to graph it quickly. So y is less than 5. So we often have a difficult time remembering whether or not this is a slope of 0 or a slope of undefined. But first of all, let's consider where we're going to cross 5. Is it going to be on the y-axis or on the x-axis?
Y.
It's going to be on the y, because we're talking about y. 1, 2, 3, 4, 5. So I'm going to plot on 5. So is it going to be a horizontal line or a vertical line? It's going to be a horizontal line. Is it going to be dashed or solid? Dashed. Why? Because it's less than, not less than or equal to. Uh-oh, I didn't use a straight line. That's okay. We're just doing a rough sketch. All right, so now, let me change my pen. Now we need to decide whether we're going to shade above that line or below that line. Below this line. Now let's look at this one. This is already in slope-intercept form, so where am I going to begin? At 1. Let me change my color. Begin at 1, and I'm going to go up 2 over 1. Another rough sketch. Am I going to shade above that line or below that line? Above the line. So wherever they're both shaded, which is right in this region here, would be the solution. So is 2, 3 a solution? Let's go over 2. 1, 2, up 3. 1, 2, 3. Is it a solution? No, it's not a solution. Would negative 2, 3 be a solution? Yes. Anything in this shaded region would be a solution. So that would be another way to solve. What about this one? What is similar and what is different about the 2 lines? Anthony? Excellent. This one is an equation. This one is an inequality. What's something that's similar about them? Michael? The slope is the same, and the y-intercept is the same. Good. All right, so today we're going to be reviewing for our Chapter 5 test that we're going to have tomorrow. If you see an equal sign, it means that we're going to be solving by either graphing, substitution, or elimination. If you see an inequality sign, it usually means you're going to be using graphing. Now, before we get into this, I want to show you one more thing. Let's just consider a scenario. Really quick. I think this helps. So let's consider if I'm going to an amusement park, but it's a special amusement park, all right? It's got special restrictions. So the first restriction is that you have to be over 50 inches. So let's just say this is counting by 10. So over 50 inches would mean you'd have to either be, does that mean you can be 50 inches or you have to be over 50 inches? Over, which would be greater than. So would I have a solid line or a dotted line?
Dotted.
Dotted, because greater than means not 50 inches, but more than 50 inches. So I would have to shade above this line. But what if, we're going to call this height. So the other restriction is that I also have to be 10 years old. So we're going to go out here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I must be 10 years old or older. Is 10 years old or older going to be a solid line or a dotted line?
Solid.
Solid, because I know I can be 10. Oh, that's not exactly on there. Put that right there. So I can be 10 or more. So I'm going to go ahead and shade that a different color. Here's 10 or more. So what systems of equations show us is where both cases interact. So if I go to this amusement park and I need to be both taller than 50 inches and I must be either 10 or older, that means that only this group of people that go are actually going to be let on a ride. What if I'm 55 inches? It matters how old you are, because this is all the people that are above 55 inches. But if they're not older than 10, they can't go on the ride. What if you're 12? Can you go on the ride?
How much do you weigh?
No, it depends on how tall you are. So just because you're 12 doesn't mean that's a solution to both scenarios. Now let's compare that with systems of equations. A system of inequality is talking about things that are greater than or less than. A system of equations is talking about something specific. What's that thing that's specific? How do we find a solution with a system of equations? What does it usually look like, Elgin? A system of equations? It has one problem and another problem. Those are lines. Where's the solution to those lines? Where they intersect. So if I were to say that only people that are, I guess it wouldn't work on this one because it says greater than 50, but if this was solid and it was over 50 inches, a solution to an equation would be if you are 50 inches and you are 10 years old. That would be a point of intersection. You understand what I'm saying, how there's a difference between that? Okay. Does that clear things up just a little bit? How they relate and how they're different? Okay, so let's go to our review. Okay, when solving a system of equations, if you get a solution of -1 equals 11, how do the graphs of the equations appear? All right, this is a really good question because this explains or demonstrates whether or not you understand what happens when you're manipulating these equations. So what happens when I'm solving for something and I get, let's say I eliminate my y's and I come up with x equals, I don't know, I'm not going to solve it, x equals something. What's our next step? Substitute it back into one of the equations, and then we get ourselves a solution. Well, what if during that process, what if I get -1 equals 11? I don't get x equals, I don't get y equals, I get this. It never exists, right? Does -1 ever equal 11? No. So we just found out that there is no way that these two things have anything in common, therefore, this is no solution. What type of lines have no solution? Parallel lines, because a solution means an intersection between two lines. If there's no solution, there's no possible time that these lines are going to intersect. They must be parallel. Questions on that? All right, next one. When solving a system of equations, if you get a solution of 0 equals 0, how do the graphs of the equations appear? Does 0 equal 0? This one's difficult. Because most students look at this and say, oh, that's a point on the center of the graph, or the origin. But that's not what they're saying. Sometimes it's easier if you say something like 4 equals 4. Does 4 equal 4? Does 5 equal 5? So this time, we're also not getting a solution. We're not finding x, we're not finding y, we're not finding anything, right? But, you know, we're finding that no matter what I put in there, I'm always going to get the same thing. So that means it must be the same line, or infinitely many solutions. Well, none of these say infinitely many solutions. Oh, look, this one even says the line passes through the origin. That's kind of like a distractor, right? Because some students might look at this and say, oh, I don't know, but I see 0, 0. Oh, that's the origin. The lines are parallel. Well, we just talked about that, right? That means you get something that didn't equal. The lines intersect once. Well, that means you get a solution. So it must be the lines coincide. What does coincide mean? It means the same. It means together, right? If something coincides with something else, it means that they're involved together. All right. So I think the only thing about this was this vocabulary right here is unfamiliar to you. Okay, what about this one? What is the first step? Keyword, first step to solving by elimination this system of equations. That doesn't make much sense, but let's continue. Okay, several ways to solve for this. Let's look at our options. Multiply the top equation by 2. Can I multiply the top by 2? Of course I can. Is that going to give me the easiest way or the first step to solving this equation? Multiplying the bottom equation by 4. If I multiply this by 4, I'm going to get 12x and I'm going to get 8y. Is that going to help me out? No. Multiplying the bottom of the equation by 6. 3 times 6 is 18. 6 times 2 is 12. Does that work? Multiplying the bottom equation by 2. 3 times 2 is 6. 2 times 2 is 4. Then we would have opposite coefficients if this was 4. Therefore, D is the correct answer. Questions on that? So this one says if x equals 2 and 3x plus y equals 5, what is the value of y? Well, sometimes this is unfamiliar to you as well. You haven't been seeing them when they're horizontally lined up like this. So let's line it up. I'm going to change. Is this working better, the thinner pen? I use this for geometry. I think this one's better. And actually, I can use this pen. So let's do 3x plus y equals 5. Because I'm writing proofs, and I have to write really small, and x equals 2. Okay, so how would I solve this particular system of equations? Exactly. I know that x already equals 2, so the easiest thing to do would be to substitute 2 in for x. It's asking me what is the value of y. That's important too, right? All right, so 3x's plus y equals 5. I know that x equals 2, therefore 6 plus y equals 5. I'm not used to using this type of pen. I need to keep you guys try and remind me, okay, when I go back and forth, because it's neater. Y equals -1. My answer is -1. Questions on that? Am I going too fast? Not while I'm recording and trying to help everybody be able to review at home, right? Okay, use the graph. Find how many solutions exist for each system of equations. So, tomorrow I will have highlighters for you. By having highlighters, you can identify solutions easier. So, y is equal to -3x plus 2. Let's find that one. Right here. That's this line. Oops, wrong one. There's just all kinds of... Okay, I need this one. That line right there. And y equals 2x is this line right here. Look at Christmas colors. Is that one solution? No solution, cannot be determined, or infinitely many solutions? One solution. Again, what does infinitely many solutions look like? Same line. What does no solution look like? Parallel. Cannot be determined. I don't know what that means, right? You can always figure out whether there's a solution or not, right? Okay. Next one. When solving a system of equations with substitution, specifically, what would be the fastest first step? This one you have to be careful on. Remember, the test is going to look just like this, but you're going to have distractors, and please don't pick whatever we picked here, because am I going to have the exact same problem? No. Vanessa, looking up. Solve the first equation for y. What do I do when I solve the first equation for y? What's my first step when I do that? I would get y by itself. In order to do that, I would first have to subtract x. That's number one. Got it? What comes next? All right, 2y equals -x plus 15. What would be my next step? Divide everything by 2. This isn't looking like a very short step. Okay, so I don't think A is it. Solve the first equation for x. If I solve the first equation for x, what would I have to do? All I have to do is subtract 2y. And I would get x equals -2y plus 15. Maybe multiply the first equation by -5. If I multiply the first equation by -5, then these would get eliminated, right? Would I be, now that's the way to do it, right? But did it say to eliminate? It said to substitute. That's out. Multiply the second equation by -2. What's that going to do for me? Well, it'll eliminate the y. Did it ask for elimination? Nope, it did not. Are these correct if you're trying to eliminate? Yes, but we're not asking for elimination. See how these questions are very, very specific? It judges whether you really understand what you're doing. This multiple choice test is not easy. Very specific. You don't get why? Thank you for correcting yourself. You don't understand why the answer is solve the first equation for x.
I mean, I know why, but you solve for why.
It doesn't matter which one you solve for, and this one's saying, how could you substitute? Okay, understand? All right, good job, guys. I'll put this up. Have a great day.